Here's a fascinating story about past glaciation in the northeastern United States. I'm here in northwestern Vermont, and I'm going to take you on a tour in this video of some features on the landscape that have been left by glaciers that remind us that this area was once covered by a mile-thick sheet of ice. Then the climate changed due to changes in orbital pattern, and the ice melted away and it left signs of the past glaciation, including these marks in the ground. These are called glacial striations, and they were caused by advancing glaciers dragging little bits of sediment and rock along underneath them and scraping the ground, leaving these streak marks. Then the ice all disappeared, leaving this. So in this video, I'm going to take you on a tour of several features like signs of past enormous glacial lakes, some glacial till, some glacial erratics, and some features that you can really only see from aerial or satellite imagery. So, let's go. First, glacial valleys in the area, starting with Crawford Notch, New Hampshire. Notice the pronounced U-shaped valley carved out by advancing glaciers. Next, we'll head up to the beautiful Lake Willoughby in Vermont. Lake Willoughby also sits in a U-shaped valley with steep, polished cliff sides, a clear indication of past glacial activity. Similar to the U-shaped valleys of New Hampshire and Vermont, another landscape feature in the northeastern U.S. that shows that glaciers were present in the past is the Finger Lakes region of western New York. So let's zoom in on this feature right here, and we can see these long, slender lakes that were carved out by advancing glaciers. And in fact, the deepest point in two of them, Cayuga Lake and Seneca Lake, are below sea level. And this can only be possible by the action of scouring glaciers and not by flowing water. That would be impossible because the flowing water could not get below sea level. If we go just north of here, another interesting feature emerges. All of these little mounds right here, these are called drumlins, and they are made up of glacial sediment, glacial till, like a mixture of various sizes of sediment. And they were deposited by advancing glaciers in these formations that are oriented parallel to the direction of the glacial flow. So this makes it pretty easy to interpret the direction of the glacial advances where these occur. And then glacial erratics. Glacial erratics are boulders that have been picked up by glaciers. This is the Madison boulder in Madison, New Hampshire. This is the largest known glacial erratic in North America. It is enormous. It's hard to imagine this thing on a glacier. But these types of erratics are scattered all about this area. This is just far and away the biggest one. Here it is from the other side too. But you have to also remember that this is just the top side of it. There's also about 10 feet or so that have been buried underneath the ground here. Here's a smaller glacial erratic right in front of the giant. Over the course of about a couple thousand years or so, as the orbital patterns continue to change, leading to warming and the retreat of the glaciers, all of the meltwater eventually made it to the ocean, raising sea levels dramatically. In doing so, several large proglacial lakes developed in front of the retreating glacier. I'm going to focus in on one in northern Vermont right here. So this is Glacial Lake Winooski. So you can see the retreating ice in this diagram on the left-hand side, and I'll show you some features on the ground, including at Waterbury Reservoir right here, and then we'll go down to another site down here in Waitsfield, Vermont, where you can also see sediments left behind by this glacial lake. Now this is a proglacial lake, similar to ones that we can see nowadays. For example, here's one in Iceland, and here is one in Patagonia. And each of these have glacial meltwater right in front of the glacier themselves. So we'll take a little trip to Waterbury Reservoir, and we'll look at some of the glacial deposits left behind by these glacial lakes. This is called varved sediment, and you can see these distinct layers of clay that have been laid down by the glacial lake. The way this works is the proglacial lake, the fine sediments that have been ground up by the glacier are stirred up by wind in this glacial lake, which gives the glacial lakes that typical color. Then in the winter, when ice forms, there's a barrier between the wind and the water below it. So the sediment all has a chance to settle out and form one of these layers that you see below there. So these layers form annual deposits. And the other thing that's going on here is that during the summer period, when there's a lot more meltwater off the glaciers, coarser sediment can enter the water. So this can lead to coarser sediment and then fine sediment in the winter and then coarser sediment and so on in these annual series. The result is these very dense, fine clay deposits, like shown here. There's another site in Waitsfield, Vermont, near a popular mountain biking trail where I like to go mountain biking in the summer. Right off the trail is another great example of varved sediment. This is from that more southerly location in that diagram that I showed you before. Very distinct layers are visible here from these annual clay deposits. Here's a pretty good sized mass failure next to Freeman Brook in Warren, Vermont, in central Vermont, in the Mad River Valley. And it's a good example of glacial tills being exposed. So glacial tills are just kind of poorly sorted sediment materials that have various sizes. So you'll find a lot of very fine sediment in here, as well as some very coarse pieces, and it's just all sort of mixed together. Here's some more glacial till being exposed. It's not that great to see it right now because there's some fresh snow on the ground, but here we go. This is the sort of stuff that we're talking about. Just various sizes mixed together with some fine sediment as well. Now this glacial till covers most of the land surface in the state of Vermont. You can see it in the pink color right here. So as you can see, these glacial tills are kind of everywhere, and it's just a dead giveaway as to the extent of the glaciation here in the Northeast. One other common thing to see is in farmers' fields, you'll often see these piles of the large chunks removed. It's really hard to farm with this stuff. So those aren't even all the glacial features on the landscape. There are some that we didn't even talk about, like eskers, for example. And there's also kettle ponds. Kettle ponds are neat. They're formed when large chunks of glacial ice fall onto the ground, causing an indentation. The ice melts away, and then the indentation is left, which can get filled with water. And they're sort of dotted all over the landscape, and they're frequently found around here. Oh, and we have only just scratched the surface. I just showed you just a tiny fraction of the features on the landscape. There are countless more that would make this an hours-long video if we visited them all. And I just don't have time. But I would love to hear about them. If you know of something nearby that, that we didn't talk about, I would love to hear about it. Put it down in the comments, and I would love to learn about it. But to keep this from getting too long, let's call this part 1 and keep it at that for now. There is one other really interesting story that relates to the glacial history of this place. And it has to do with how an Arctic whale was left high and dry on the land surface down in Charlotte, Vermont, after the retreat of the glaciers. And so if you're interested in that, then check out this video here. Okay, So that's it for now. Thanks for watching. I'll see you next time.